Lesson 2, Triangles Part 2. So just two more examples with triangles. These ones are a little bit more tricky. So Sandra is a surveyor. She needs to measure the distance between point A and B, but a glacial erratic prevents a clear line of sight to measure directly. If Sandra positions herself at point C, D, or E, she can measure the distance from this position to both A and B, as well as the angle between the two lines. So let me just draw this for you. So we have, so we're going to call this point A, and this is on the ground, and this one is point D. And if we go straight out, she could stand here at B. And she needs to find the distance between A and B, but she can't because there's some sort of glacier or something. I don't really know what any of these things are. So what she can do though is, instead of standing directly in that line of sight, she could stand somewhere over here. It's hard because this is like 3D. So she could go there, oops, and stand at point C. So it would be on the other side of the glacier. Or she could go stand way over here on this side of the glacier. We're going to call that point E. So basically she could go on either side of it and she could measure, but she can't really go directly because the glacier's in the way. So she cannot, it says, explain why Sandra is not able to find distance AB by standing at point C or E. So that's not really going to help her. And the reasons why is she can't measure AB. She can't do it because there's something in the way. Right? And she can't measure A to C, C to B, A to D, D to B, A to E. She can't find all of these angles. Those are the things she can measure. She just can't actually measure that physical distance. So we're going to assume this is 90 because we're going to assume that's on the ground, or that she has been measured. And part B tells us that she's positioned herself at point D, and she has measured that distance A to D is 15, and she's measured that D to B is 20. So these other points are really irrelevant because it doesn't matter, because she can make this right triangle regardless of if there's actually something in the way. She doesn't need to physically measure it. So it's just the Pythagorean theorem now. 20, 15. So the distance between A to B is going to be the square root of 15 squared plus 20 squared, which is the square root of 625, if you type that into your calculator. So it's actually going to be 25 meters across. Example 2, you have a pyramid that has a rectangular base. And it's 4 feet by 6 feet. And the height of the pyramid is 6 feet. So here's our pyramid. The height is actually a strange thing because it's actually measured from the center of the pyramid to the top. And that doesn't always help us because we need to know what the slant is. The slant is that outside measurement. So we'll measure this right now. So we know the height's 6. We're going to draw a net of this. So the net would make a rectangle, and then it's going to have two triangles that look like this, and then two skinnier triangles that look like this. So this question tells us to draw the net of the shape and determine all the types of triangles that are formed in this pyramid. So first off, we're going to write in what we know. So we know that this is 6, this is 6, this is 4, and this is 4. we need to find the height of the triangle. So that height is actually this outside, what we call the slant. So the slant is this kind of outside thing. So if I want to find that green slant right there, that's on our wide triangles. If you look between the green and that red line right there, it makes a right triangle. And this length right here is going to be half of the base. So to find that green slant, we're going to use a base of 3 and a height of 6. So now we can use the Pythagorean theorem. So we're going to call it, let's call it S, not H. The slant is equal to the square root of 6 squared plus 3 squared, which would make 6.3. So that's going to go with these skinny triangles. If we want to find the slant of the other triangle, it's kind of hard because we're not looking at it. We actually need to take half of this side. So to find that slant, we would use 6 and half of our other side, which would be 2. So our second slant is equal to the square root of 6 squared plus 2 squared. And if we type that into our calculator, we would get 6.3. Sorry, the other one is 6.7. That is my bad. I was looking at the wrong number. So 6.3 for this one, 6.7 for that one. And if we were to classify these triangles, these triangles would all be isosceles. And the reason is that all of these sides are going to have to touch because they meet up to make this pyramid. So they are all isosceles. If we want to find that length, we just have to do it with one of the triangles. It doesn't matter. So let's look at this one right here. We have this triangle. We only need to look at half of it. So we know it's 6.3. We know the base is 6, so this side is going to be 3. So we're going to use the Pythagorean theorem now to find that outside, which is going to be all of our connecting triangles. So we're going to say x is equal to the square root of 6.3 squared plus 3 squared. Type that into your calculator and you should get x to be equal to 7.0. And if you do it with the other triangles, it will work, but all of these outside sides are 7. And they have to be, because otherwise they wouldn't meet up. So just be really careful when you do the pyramid, when you're finding those slant sides and which side you're going to do the half of.